Need to make what the subject?
X.
So, okay. So you're suggesting that we find f of inverse x, right? That's like the first
Yeah.
step. So for that, okay, so we make x the subject. How would we do that?
We don't have the left side though.
For the function in the question?
Yeah.
We do. We have f of x. If you remember, first step is to replace f of x with y. So it becomes y equals to 2x plus 3.
So
Right?
now I have to
Yeah. So
put
now,
y 3, take it to the left side, so it'll be y minus 3.
equals to 2x, and then y
Divide
minus
both
3
sides by
by
2.
2. That's right. So now x is the subject, and we replace x with f of f inverse x and y with x. And this is our inverse function. Okay?
Okay.
So now we have the inverse function, we have the original function. How would we sketch these two? What are the first steps in sketching a graph for any function, whether it's linear or quadratic?
We have to put in the values,
Which values?
like the y and the x.
That's right. How do we do that?
We don't have the x though. No, we do have the x, but
At the moment, we just have the f of x and f inverse x equations. That's it.
yeah.
So if you remember, we find the x-intercepts and y-intercepts, right?
Yeah.
So how do we find the x-intercept?
The x-intercepts.
Hmm. Don't remember?
No, I know how to do it. I just
Okay, wait, I'll do this one. So we put y equals to 0 for the x-intercept. So that would be 0 equals to x minus 3 over 2. 0 times 2 is 0 equals to x minus 3. And 3 equals to x. This is one point for your inverse function. Now we find the y-intercept. So we put
x
x equals
0.
to 0. That's right. So y would be 0 minus 3 over 2, which is negative 3 by 2, right?
Yeah.
So these are the two coordinates for the inverse function. Now we repeat the same for your original function. So, one second. X-intercept would be what then?
3 and 0.
3. Yeah. Oh, wait, no, 3 and 0. 0 equals to 2x minus 3. 3 divided by 2 equals to x. If you remember what I just told you, the domain and range of your inverse would be the opposite for the original. So if you look at the coordinates now, one second, let me just find the other one as well. The roles have switched. Whatever was the range for the previous one is the domain for this one. Do you notice the similarity?
Yeah.
The numbers are still the same, but their roles have changed. For the original one, your domain is -3/2 and your range is 3. But in the second one, your domain is 3 and the range is -3/2. So now
Yeah.
that we have the coordinates, we sketch these. So we draw the axis, y-axis, x. Then what we do is plot the points. So let's start with the original function 0, 3. Let's say d is over here and -3/2 0. So let's suppose that is over here. So we connect these points. Okay. This is y equals to f of x. And for the other one, it's 3, 0. So that's going to be, let's say, over here. And 0, -3/2. So let's suppose that is over here. So we once again connect the points. Okay. So this is going to be our y equals to x line, which is going to play the role of reflecting the both graphs. And this is our y equals to f inverse x. Do you get the entire thing now?
Yeah.
Like they're both reflections of each other in the y equals to x line. That's like the basic point of this.
Okay.
And you get the sketching part and the intercepts and everything.
They're just symmetrical, right?
The what, sorry?
So they're basically symmetrical, right?
Yeah, exactly. Look, they're reflecting each other in the y equals to x line. So the y equals to x line is acting as a line of symmetry for these two functions.
Yeah. Okay.
Any other question?
No.
Okay, perfect. So now